In this video, we're going to look at how to create a simple profile using RAMP. In a previous video, we introduced the main concepts involved in profiling with RAMP. So if you haven't seen this video, check it out because it explains some of the terminology that is frequently used with regards to profiles in RAMP. So for this tutorial, we're going to follow the RAMP profile workflow. Firstly, we're going to generate what's known as a seed profile. Then we're going to densify that seed profile both longitudinally and in the cross and offset directions to create a bare profile. And then finally, we're going to append values from a raster dataset to create a populated profile. And then we'll open that profile up and see what it looks like in the RAMP profile viewer. So if I start the profiling processor in RAMP, you can see that there are a number of methods in here that relate to the main workflow steps that we just talked about. So generation, densification, and appending. So you can see that there are many ways to generate a seed profile within RAMP. You can, for example, import a set of coordinates from an ASCII CSV file. You can define your profile lines in an Esri shapefile, so digitize them in ArcGIS, for example, and bring them in. And you can import a number of standard industry formats that help define profile lines, like a UCOA P594 file for pipelines, and the VisualSoft VisualWorks sail line files, and also some of the main IVA runline, track, and flag files as well. So importing any of these will help you generate a seed profile. But we're going to do something a little bit different and get the RAMP GUI to help us out to generate a seed profile in this case. So firstly, I'm going to add my favorite terrain raster, and I'm going to render it. Okay. If you remember, there's actually a profiling tool built into the RAMP GUI. That's here. I simply click on the pencil and define the start and end coordinates that I want for my profile. So I can see a really basic profile drawn along this data set at that line in this view here. One of the options I have is to actually save the profile. So if I click Save, you'll see I have a number of options. I can export the profile and all of the data in it as a ASCII CSV file so that I can import it into other software and do something with it. I can generate a RAMP populated profile that will create a RAMP version of this particular profile. Or I can generate a RAMP seed profile. That's what we're going to do. That's essentially going to create an empty profile. Save. And that's done. If I inspect that profile now, let's have a look what it looks like. You'll see that it's got a header line, it's got a flag that indicates what the node data value is, and it's got a series of field descriptions that are based on the field names that are defined in the header line. So in this file we have a distance, an offset, and an X and Y coordinate. And you can see that is captured here. The start distance is 0, and the end distance is 1039.7 meters. This is followed by the offset, which is 0, and then a series of coordinates. So offset 0 means the center line. Okay, but there's only 2 points in this particular profile. So now we need to densify the profile longitudinally. Let's do that. Using the profiling processor, I'm going to choose the option to densify the profile in the longitudinal direction. So let's take that profile file, and we're going to say let's create a point that's every 10 meters along this profile. I don't need to specify an ellipsoid because the data is projected. Let's see what this does. Okay, and now let's go and have a look at that file again. So my ASCII data inspector, and I will open that profile file. Now you will see that there are points created every 10 meters along the profile until the end of the profile, which is at 1039.7. Okay, so this profile is still bare. It doesn't have any attributes attached to it. It has still just a distance, an offset, and the X and Y coordinates. There's no actual value. So let's look firstly at densifying the profile in the cross direction or the offset direction. So densifying in the cross or offset direction, there's a separate method for each. Essentially, when you densify in the cross direction, you basically are telling it how often you want to create points offset from the center line. And it will create those points at the intervals that the profile has been longitudinally densified at, but it does them in the perpendicular direction. So we could say, in this case, we could say, let's go either side of the center line. We're going to go 20 meters, and we're going to increment it every 2 meters. So that's going to create 10 offsets on either side of the center line. My other option, of course, that I could do is I could specifically specify the offsets. So this is normally used when you want to generate, say, offset profiles. So you have maybe you're building a geological profile and you want to offset your center line 200 meters to one direction and 200 meters in the other direction, and then you would use densify in the offset direction. Essentially, they do exactly the same thing, but in one you specify a width, and it's generally used for creating cross profiles, and in the other you specify specific offsets, and that's generally used to generate offset longitudinal profiles. Let's go with this option. Again, I don't need to specify an ellipsoid. So let's generate a swath width of 20 meters either side of the center line. Okay, and let's look at that file again. Now you'll see that there are offsets at -20, -18, -16, blah, 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 all the way up to 0, and then again from 0 all the way to +20. So it's created these perpendicular offsets and calculated the coordinates for those at 2 meters either side of the center line, this being the center line record, and out to a width of 20 meters either side. Okay, so this is still a bare profile. It doesn't have any values attached to it apart from the definition of the profile itself. So the distance along the profile, the offsets, and the X and Y coordinates. So now let's go and look at how we might append data to this profile. So back in the profiling processor, you will see that there is APPEND. Now, APPEND works in two different ways. You can append data from a raster dataset or a series of raster datasets, either using a preferential method or using a stacked method. The stacked method is what you would normally use to create a geological profile. The RAMP help documentation explains this better. If I was to identify or define two different raster datasets as my input, so for example this low resolution dataset highlighted in red here, and then this high resolution dataset as a strip in the middle. With preferential, I can identify that the green dataset has precedence over the red dataset. And that means that when I generate the profile, or append data from those rasters to the profile, it will create a single value field, but it will preference data from the highest order or highest priority data set first, and then if that's not available, then it will go to the next preferential data set. So that's preferential assignment or preferential appending of rasters to a profile. The other method is when I have a stacked method. So this is, as I mentioned before, when you want to create geological profiles and you might have, say, a number of horizons in your data that you want to create as separate value fields within the profile. As we're only going to be adding one raster to our profile, it doesn't actually matter which method we choose. So let's go back and have a look at that again. Profiling, append. Let's choose append preferential. And I'm going to choose my profile file again, and I'm going to choose that as the input raster. I'm going to call this value field seabed, and I'm going to ask it to interpolate using bilinear. I find that smoother. Let's run this now and see what happens to the profile. Okay, let's have a look at the data. Whoops, the ASCII data inspector. You'll see now that it's added a field here called seabed, and it's added a description for that field in the comment below here, and it's added the value of that to all the records here. So that's what the file looks like in a text editor. Let's now open it in the RAMP profile viewer and see what it looks like. So the RAMP profile viewer tool is here. This is what it looks like. And I am going to open that profile. Okay, so you can see in the profile viewer, this is my map view, and this is where I drew the line originally. This is the actual profile, and these are my cross profiles, and each of these listed here are the offsets. This listed here are my value fields in the profile. So what I can tell is I have a single value field that's called seabed, and that's displayed as a blue line here in the longitudinal profile. It's also displayed as a blue line here in my cross profile. I also can tell that I have -20 to +20 offsets about my center line, which is offset 0. If I want to, I can go and make any of these other offsets visible in the longitudinal profile by making it active here. I can also make any of them visible. So you will see that the profile 0 is now the active profile, and the dotted, and so it is drawn with a solid line, and the offset profile at -20 is drawn with this dotted line. So you can see that these profiles change. Let's put on the +20 profile, and that's also now drawn with a dash. So you can see these offset profiles in here. Let's turn off these because it's a bit confusing, and we'll just go with offset 0. In my cross profile, I can see that my profile is centered at offset 0, and I have all the values out to -20 and +20 down here on the x-axis. Let's do something. We need to set up the units of measurement. So the distance units here are meters, the cross profiles are in meters, and the coordinates happen to be in meters as well. Let's step through the profile now and let's move every 0.5 meters. And if I click play, you can see the profile slowly stepping through, and you can see the seabed changing. Let's speed this up a bit. Let's go take 1 meter steps every 0.2 seconds. Let's make that a little bit faster, shall we? So that's slower. Okay, and I can see my seabed cross profile changing as we crawl up the mound here, and we'll see this big dip on this particular one as we come up to it in a second. There we go. You can also see the location of the cursor. So this is the distance along profile, and you can see that here in the map view. So that's a quick introduction to the ramp profile viewer and how to generate a very simple profile using the ramp processes. One of the things that we will look at in a future video is the ramp profile viewer in a lot more detail, because there's a lot of functionality in here that can be useful in terms of generating graphics and exporting files to graphical formats. So thanks for watching this video, and I hope it has been useful to you.